In this video, we're computing the integral of an ugly rational expression, and the natural tool to use here is partial fractions decomposition. Now, when we propose a partial fractions decomposition, the idea is that a proper fraction can be broken down into a sum of a bunch of other proper fractions that are smaller. And what I mean by proper fraction is the degree of the numerator must be less than the degree of the denominator. So the rational expression we're looking at here has a problem. We need to knock down that degree. And that's when we start with polynomial long division. So we're going to take x cubed plus 2 and divide by x squared plus 2x plus 1. Note that we're going to need some placeholders. We need a 0x squared in here. We need a 0x. And then we have our plus 2 at the end. And then we start to guess the thing that we multiply x squared plus 2x plus 1 by to get this polynomial at the bottom, plus possibly a remainder. So we'll start with an x and distribute that over x squared plus 2x plus 1. Then we find out how much we missed by. In other words, we subtract. The x cubes cancel here, and I end up with a negative 2x squared and a negative x, and then I have a 2. Now we move to the constant part of our guess, and that would be a negative 2. So I can match that negative 2x squared in the leading term, and I get a minus 4x and a minus 2 as well. And again, we subtract. The negative 2x squareds cancel. Negative x minus negative 4x is positive 3x, and 2 minus negative 2 is plus 4. And remember, the interpretation of remainder here is that we're left with a 3x plus 4 divided by x squared plus 2x plus 1. All right, so our integrand can be represented as x minus 2 plus this fraction. And now we're going to factor the denominator of that fraction and propose a partial fractions decomposition. So we could write that fraction as 3x plus 4 divided by the factored denominator. And this denominator looks like it factors into x plus 1 times x plus 1. In other words, x plus 1 all squared. Recalling the partial fractions decomposition rules. So these rules are set up so that the partial fractions decomposition is guaranteed to work. I need a term that looks like a constant over x plus 1 in addition to a term that's a constant over x plus 1 all squared. Now we can clean things up by multiplying both sides by the least common denominator, which is x plus 1 squared. And this leaves us with a 3x plus 4 on the left-hand side. And on the right-hand side, when we distribute x plus 1 squared to the a containing term, one factor of x plus 1 is going to cancel, but 1 survives, and I end up with a times the quantity x plus 1. In the b containing term, the denominator cancels that x plus 1 squared completely, and I'm just left with a b. And this equation isn't too hard to solve by just collecting the coefficients of the different powers of x. So on the left-hand side, we have 3x plus 4. On the right-hand side, I have an ax. That's the only x containing term, and that means a is equal to 3. I also have a constant, and that's just a plus b. So again, we compare the coefficients of like terms, and I end up with a equals 3. Then when I compare the constants, I end up with 4 equals a plus b. But I just said a is 3, and that means b is equal to 1. So now that we found a and b, we can replace this rational expression part in the remainder with our partial fractions decomposition. Don't forget to keep the x minus 2 out in front, so let's rewrite the integral. And now each of these pieces can be integrated with a simple guess. So I have, applying the power rule to the x, I have 1/2 x squared. The negative 2 integrates to negative 2x. The 3 over x plus 1, that's a natural log type of antiderivative. The 3 is a spectator here, and I have the natural log of the absolute value of x plus 1. And 1 over x plus 1 quantity squared, we have to view that as x plus 1 to the negative 2. And that integrates to x plus 1 to the negative 1 divided by negative 1. Well, that just puts a minus sign out in front. And x plus 1 to the negative 1, that's a 1 over x plus 1. Don't forget to add the plus c. And this one is done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.